This is a Ruby laser that I built. It's of the same type as the very first laser ever made by Theodore Maiman at Hughes Research Laboratories back in 1960. I built this laser to allow my AP Physics C students to experiment with a high-powered laser because it's kind of fun to do that. My laser consists of a high-voltage power supply, and the high-voltage current goes into this control module here, which is the charging firing module. This module allows me to charge up the laser and fire it in a controlled way. And the firing is done by pressing this firing button here. That high voltage current comes out of the charging firing module and goes into the pulse forming network, which is in this acrylic box here. And that consists of a number of capacitors here and also an inductor over here. And so that high voltage current charges up those capacitors, and when I hit the firing button, that energy goes into firing a flash lamp, which is right here. And this flash lamp extends through a highly polished elliptical cavity and comes out the other end here. And the flash lamp is at one focus of that elliptical cavity here. And at the other focus of the elliptical cavity is this ruby rod, which is right here. And therefore, the light that comes off the flash lamp gets focused onto that ruby rod. And when that happens, it raises the chromium atoms in the ruby rod from a low energy or ground state up to a higher energy state. Now, one of these chromium atoms might spontaneously drop down into a lower energy state and release a photon of red light. And the photon is going to bounce back and forth between a pair of mirrors here. A highly reflective mirror here and a partially reflective mirror here called an output coupler. And when the photon bounces back and forth, it encounters other chromium atoms, which are in the higher energy state. And when that photon encounters one of those atoms, it causes a stimulated emission in the atom it encounters, and then two photons kind of move off together in unison, and they in turn will encounter other atoms in a higher energy state and cause them to undergo stimulated emission. And eventually you have all these photons moving back and forth between the two mirrors in a very highly organized way. They're all in phase with one another. And eventually this beam sort of breaks through the partially silvered mirror here in the form of a very bright, intense laser pulse of red light. And so that pulse only lasts about 1 millisecond. So it's bright and it's brief and it's kind of cool. So let's fire this thing up to see how it works. So I'm going to come down here and turn on the high voltage. And then I'm going to press the charging button here. Make sure that's on. Press the charging button of the charging firing module. And you can notice that the needle on the pulse forming network is going up toward 100%. That means the capacitors are being charged right now. And when they get up to 100%, I can fire the laser. So let's get pretty close there. So what I'm going to do is I'm going to take my hand off the charging button for a second so I can put this flash shield on. And then I'll come back and continue the charging up to 100%. And I got my laser pointed at a balloon here, so maybe we can pop a balloon when I fire it. And I'm going to do that in 3, 2, 1, fire. And that is how my Ruby laser works.